Hello all, good morning. This is Dr.S.Subhalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This video is a continuation of the previous video on the topic partial differential equations. In the previously we have seen the partial differential equations formation, and in which we have seen only type 1. Moving on to the second type, which is type 2, where the condition goes like this: number of arbitrary constants is greater than the number of independent variables. Here we have to use, according to the given question, the order of the partial differential equation. So moving on to the question: form a partial differential equation by eliminating the arbitrary constants a, b and c from the equation z is equal to ax plus by plus c into xy. Here obviously we say that x and y are the independent variables, z is a dependent variable, and a, b and c are the arbitrary constants. Here we see that the number of arbitrary constants is greater than the independent variables, so we are in the form of type 2. So on moving on to type 2, we are in need of eliminating 3 arbitrary constants here. So we are in need of using all the first order and the second order derivatives which we have given earlier. So we have first take the given equation z is equal to ax plus by plus cxy, which will be marked as first equation. So as usually we are going to differentiate partially with respect to the variable x and y, and therefore we get dou z by dou x is equal to p, as seen in the previous video, which is equal to a plus cy. Here the variable to be considered as x and to be differentiated as x and not y. Y will be considered as a constant here. In the third term, x is the variable and therefore c and y are the constants, therefore the third term goes like cy. In a similar way, we are just differentiating z with respect to the variable y partially, which is equal to q, which is equal to b plus c into x. We are just marking those two equations as 2 and 3. Again, we are just differentiating the equation number 2 with respect to the variable y, and therefore we will be getting the second order derivative of the partial differential equation, which is s, which is equal to c. We are just marking that as fourth equation. Again, we are going to differentiate the equation 3 with respect to the variable y here, and therefore we will be getting dou square z by dou y square, which is equal to t, which is equal to 0. And also we are just going to differentiate the equation 2 with respect to the variable x again, therefore we will be getting dou square z by dou x square, which is also equal to 0. We are just marking this particular equation as sixth equation. So as we can see here, s is also equal to 0 and t is also equal to 0. That particular equations can also be said as the partial differential equations for the given format. So on substituting all the equations here, we have q is equal to b plus sx, which implies b is equal to minus sx plus q, and t is equal to a plus sy, which implies a is equal to minus sy plus p. So instead of saying this s and t to be 0, we can just substitute the values of a and b in the given equation so that we eliminate the arbitrary constants here. Already we have seen that c is equal to 0. So z is c is equal to s, and therefore we are substituting the values of a, b and c in the given equation 1. Therefore we have z is equal to minus sy plus p into x plus minus sx plus q into y plus sxy, therefore which is equal to, and finally we have z is equal to px plus qy minus sxy, which is the required partial differential equation using type 2 concept. Here we have applied all the derivatives, all the first order and the second order derivatives to form the PDE alongside the given question. Moving on to the second question: form a PDE by eliminating the arbitrary constants a, b and c from the given equation x squared by a squared plus y squared by b squared plus z squared by c squared, which is equal to 1. So marking this as first equation. As usually we are just going to differentiate it with both of the variables x and y, and therefore we will have the equations 2 and 3. What is 2? 2x by a square plus 2z by c square into p, which is equal to 0, which is in terms of the first order derivative, which is dou z by dou x. And therefore moving on to the third equation, 2y by b square plus 2z by c square into q, which is equal to 0, which is with respect to the variable y. So q is dou z by dou y here. So we have got 3 such equations like for the given equation, and we have differentiated for the 2 such equations. Again we are going to differentiate 2 with respect to the variable x, and therefore we have got an equation like minus c squared by a square is equal to p square plus z into dou square z by dou x square. it is just a mere simplification of the given processes. We are just going to differentiate the equation number 2 with respect to the variable x using differential concepts. So we have arrived at equation number 4. In a similar way, we are just rewriting the given equations in a format which can be applied to the given question. Therefore, we have arrived at the second equation can be rewritten as x by a square is equal to minus zp by c square, which implies minus c square by a square is equal to zp by x, which will be marked as the fifth equation. So, on substituting 5 and 4, we have p square plus z into dou square z by dou x square is equal to zp a by x on replacing it. Therefore, we have the formed differential equation will be minus zp plus x into p square plus zx into dou square z by dou x square, which is equal to 0. And therefore, all the notations are rewritten as minus z into dou z by dou x into dou z by dou x the whole square plus zx into dou square z by dou x square is equal to 0. This can be also replaced by the denotions as well. So, in this way, we have formed the partial differential equation in the type 2 format. Thank you.